We'll wait for more 5 minutes, then we'll start. Okay. So now can we start? So can we start now? Can you hear me?
Yes, sir.
Okay. Okay. So let's start now. So I'll just introduce once again what we are going to, like, what tutorial classes we are going to see. So this is the mechanics of machining classes, which with the course instructor Professor Uday S. Dikshit, IT Guwahati, and I am the teaching assistant Abhishek Srivastava, and I am the PhD research scholar in IIT Madras. So last class we have seen the concept, the brief concept about the lectures 1 and 2 content, which included, the lecture 1 included the deformation of metals, lecture 2 included the mechanics of plastic deformation, lecture 3 included the machining process, single edge tool and type of chess. So last class briefly we have covered everything, and also we have practiced some questions regarding the same. So this class will cover the week 3 content and then practice the question for the assignment 3, the practice questions. So this were the contents we covered last class: the deformation of metals, why dog bone structure is used, what are the stress strain relationships and stress strain curves, what are different points which we obtain from the stress strain curves, the difference between the brittle and ductile materials, the different formula for the elastic region and plastic region. This we have covered last time. I'm just going through so that you can have a brief look. And then we discussed about the strain hardening, necking, and then the engineering strain and stress and strain, and the true values of stress and strain. Why true value is used? I have explained why this curve is increasing, but how then, if there are true value, then why we are using the engineering stress and strain value? This we have discussed. And that then we have seen the derivation of the true stress and strain value. Then we have seen the various failure theories like the Rankine theory, Tosca theory, von Mises theory, which theory is used for which material, what are the conditions. So this we have seen. Then we have seen the machining process. We have seen single point, multi-point, abrasive operations. What is shaping, planning? What do you understand by the primary motion, secondary motion, and what are generatrix, what are directrix? Why we are using the wet shape tools? This all we have seen. Also, this all we have seen. The orthogonal cutting. What are the difference between the orthogonal cutting and the oblique cutting? And then types of chips formed: discontinuous chips, continuous chips, continuous chip with build up edge formation. What are the factors which lead to the build up edge formation? This all we have seen. And then some of the pictures of the build up edge formation. Then we have seen what are chip breakers, why chip breakers are used, and why, like, basically they are used and for which material they are applied. This are the basics of the chip breakers. And then we have seen a video of the chip breaker. Then we have different questions for the assignment 1 practice question. We have solved each and every question. In one question, one of the student had a doubt, right? Last class. Hello. Can you hear me?
Yes, sir. Hearing you.
Yeah, like for this Tresca criteria question, one of the student had a doubt last time. I don't remember the name. I think Nikhil or something. Someone was there.
Yeah, sir. That I asked actually. If we reverse the order, then the answer comes different.
Okay. So see, the thing is, for example, if I follow the Tresca criteria, then the formula is sigma yt equal to maximum of sigma 1 minus sigma 2 mod minus sigma 2 minus sigma 3 mod and sigma 3 minus sigma 1 mod. This is a formula for a Tresca criteria, right? So sigma
Yes.
yt value is given 450, right?
Yes.
So 450 equal to max
350.
450 value is given, na, sigma yt.
Oh, yeah.
And sigma 1 is how much? 150. Sigma 2 is 200 mod. Sigma 2 is, sorry, sigma 2 is 200. Sigma 3 is sigma 3. And then sigma 3 minus sigma 1 is 150. These are the mod. So this we need to find the value of sigma 3, possible values of sigma 3. To see, so we need to equate this 450 to the other equations. So first we are doing this 450 equal to this. So if one we equate 200 minus sigma 3, or we can do 450 equal to sigma 3 minus 200, right?
Yes.
You are saying this. So from here sigma 3 value would be minus 250, and from here sigma 3 value will be 650, right? You are
Yes.
saying, you were saying these two values are coming. See,
Yeah.
both values can come. It is not wrong. That your question was ki which value we should use, right? Actually you can use both values, which are not wrong, based on the options. For example, one based on the combination the option is having, you need to choose the values. So you can
Yeah.
have
But
minus 250 also, minus 650 also. These are the possible values you can have of sigma 3,
yes.
right? Is it okay?
But why? Suppose if options is not given,
Uh-huh.
and the answer is asked, if someone does in one way, he will find something, and another who is doing in different way, he will find different answer.
See,
Then both answers will be correct or wrong.
see here, however, you will find two values, one from this equation
Hmm.
and one from this equation. 450 equal to sigma 3 minus 150, right? Here also you are getting
Yeah.
sigma 3 is equal to 600, and from one equation 450 is equal to 150 minus sigma 3, then sigma 3 is equal to minus 2 minus 300,
Hmm.
right? So here however you will get two values. So option should be given, because if options are not given you can't feed one value. So based on the
Yes.
option you need to choose ki which combination is given, and you can choose it.
Okay.
So basically the different possible values you can obtain based on the option, based on the requirement. You have to choose which value you have to take,
Okay.
right?
Yeah.
Okay, fine. So okay, then we'll move forward. These were the questions. And then for the week 2 contents, we saw the tool geometry, conversion of tool angles, and mechanism of orthogonal cutting. So we saw this. Acha, by the way, like you guys were telling ki you need to understand the tool geometry properly. So you want me to explain it once again?
Yes.
We can briefly we can look, right?
Yes. Because there are lots of formulas. Memorizing is a little bit difficult.
See,
So how can I?
see, the memorizing formula is very necessary, because in exam you don't have like that time to you can analyze and draw the tools and then derive the formulas. So memorizing formula is a must. However, I can explain you very well, so that you can visualize. But in exam you don't have that much time na, you can visualize and draw the tool and derive the formulas. So the memorizing formula, you should be very thorough about that. So I would suggest कि you should memorize the formula, write all the formulas in a piece of paper, the major formula which are used, and like try practicing it. The main thing is that you practice questions so that you can easily solve it, because it has a pattern. It's not that every formula is different. Just find the pattern and you can learn it. Okay. So okay. So can I go forward?
Yes.
Okay. So see, basically last time we didn't have much time to discuss about the tool geometry. Now see, this has been already done. I'll just show you the basics of like what are the various features of a tool, and what are the various angles which are used in the tools, right? See, so the tool which you are seeing is a single point turning tool. Okay, single point means it has only while cutting or while machining, it has a single point of contact with the machine, or the major cutting edge, it has only one major cutting edges, right? Okay, see, so see, you can see. Yes, hello, hello, yeah, anyone was saying anything? One second, anyone has any doubt?
So your presentation is not coming.
Not coming. wait 1 second, huh?
Yeah.
Presentation is not 1 second, 1 second. Okay. Okay, now it's there.
Yes.
Okay.
Yes, sir.
Okay. Actually, I forgot to share the screen. Okay, we have not done much things, so it's okay. See, so this is a tool you are looking, right? It's visible, na? Right? It's visible now.
Yes.
Okay. So see, the major part of the tool which are involved in cutting is this part, this area, right? This is the rake surface. You might have heard about the rake surface. So rake surface is that surface in which the chip flows. When tool will cut the material, so some chip will be generated. Then that chip will flow over a surface which is called the rake surface. So this is the rake surface. This is the upper surface, right? And when the tool moves, so some clearance has to be provided so that the edge of the tool does not touch with the machine to avoid friction. So that area is called the flank. This is called the flank surface. So basically we have two flanks. One is a major flank, this, and one is a minor flank, this. Right? And this is the curve. This is called the nose of the tool. So basically we have four things. One is the rake surface, one is the flank, major flank, one is the minor flank, one is the nose. And the edge, this is the cutting edge through which the tool cuts. The major flank has a major cutting edge. This is called the major cutting edge. And this one, or it is also called the principal cutting edge, PCE. And this part from the minor flank, this is called the minor cutting edge, or it is also called auxiliary cutting edge, ACE. This sir has already taught. I'm just revising you. So this is a basic feature of the tool. So when you'll see about, I'll just rub it 1 second. Now let me define some of the angles, right? So first of all, can someone tell me what is rake angle? You have already learned. Can anyone know what is rake angle?
Rake surface making angle with principal plane.
Principal plane. What is principal plane?
Means reference plane.
Right. So you're right. You're absolutely right. The angle between the rake surface and the reference plane is called the rake angle. First of all, what is reference plane? So reference plane is a horizon, or is a plane at which this tool is resting. This tool is the tool rests in the plane. For example, if tool is resting in this plane, this is called the reference plane, right? So this is a reference plane. So such that the cutting velocity VC is always perpendicular to the, I am representing reference plane by pi r. So this cutting velocity VC is always perpendicular to the reference plane. That is, reference plane is that plane in which the tool rests, and the cutting velocity of the cutting velocity is perpendicular to the reference plane. So the distance between, see, if this is the rake surface is somewhat tilted, na? You can see, na, कि rake surface is somewhat tilted, and the reference plane is like parallel to, like a parallel plane. So there is some angle between reference plane and the rake surface. This is called alpha, which is the rake angle. Understood?
Yes.
Okay, na? Like, do you have any doubt?
No.
Fine, na? Okay. So there are different terms of representing this rake angle. See, when you are seeing this rake angle from the side view, from this view, 1 second. I'm just showing you properly. This is reference plane. This is, sorry, rake plane, and this is horizontal is the reference plane. So this angle which is making, this is called alpha. This is called rake angle. So when you are seeing this rake angle from this view, you are standing here and seeing here from this plane, from side view. This is called side rake angle. This is called side, this rake angle, side rake angle, right? And when we are, this is the x-axis. So when you are measured on the x-axis, it is called side rake angle. When we are seeing the rake angle from this view, front view, or you can say back view, from here, you are standing here and seeing, then this is called back rake angle, right? So the back angle is measured on this axis. This is called y-axis. This is okay. Hello.
Yes, sir.
But
Okay, right?
that angle is called side clearance angle.
What?
Side clearance angle.
Which
If we
angle?
see that by making angle with the vertical.
Okay. No. This is not making angle with the vertical. See, the definition of rake angle is same. The angle between the reference plane and the rake surface. See, this angle, this definition is common. This is always there. Ab the now is the thing is कि how you are looking to that angle. You are looking, if you are looking along the, see, if you are looking, this is x-axis, right? This is y-axis, and this is your tool. This is your tool. This is your reference plane, and this is upside is the this z-axis upside. So this is your rake surface, right? And this is your reference plane. When you are looking at the reference plane along the x-axis, right? Then this angle is called the alpha s, which is the side rake angle.
This
When-
is the top view of the tool, na?
This is a top view, yes. ठीक है. तो when you are measuring around the x-axis on the x plane, then we have the side rake angle. But similarly, if you are doing measuring on the y plane, then it is called back rake angle. Rake angle is the same, the angle between the reference plane and the rake surface. But how you are measuring, on which plane you are measuring, on which side you are looking, depends upon this which rake angle you are seeing. From the side plane or from the x plane, side rake angle. From the back plane or the y plane, it's called back rake angle. It's okay?
Yes.
Fine. Similarly, we have the clearance angle. What is clearance angle? Clearance angle is the angle between the flank and the cutting plane. So I am going to introduce one more plane. Till now you know three planes, one reference plane, one rake surface, and one flank surface, right? This is the rake surface, this horizontal is the reference plane, and this is the flank surface, right? So there is one more plane which is perpendicular to the rake surface. If, for example, rake surface is this, so there is one more plane which is perpendicular to this surface, but this plane will contain this cutting edge. It will pass through this cutting edge. You see, you understand very easily. I'm show you. See, this is the reference plane, okay, and this is the cutting plane, pi c. This pi c is perpendicular to pi r, but it will pass through the cutting edge, the main cutting edge. This is the main cutting edge. So that, see, there are different plane which can be perpendicular to pi r, but only one plane will be there which is perpendicular to pi r and also passes through the main edge, right? So that plane is called the cutting plane. That is the cutting plane. So you can see if some plane is this, which is passing through this. So difference between that plane and this angle, because it is not straight. This flank surface is not straight, now it is tilted, and that is vertical. So it will make some angle. It will make some angle. This is called what you call say gamma or delta you say, whatever you say, is called the clearance angle. Similarly, when you measured along the x plane, it is called side clearance angle, and when you measure along the y plane, it is called back clearance angle. So this is called clearance angle. Have you understood?
Yes.
Okay. Similarly, there are two more angles which are called the side cutting edge angle and the end cutting edge angle. So see, if this is the plane, this is x, this is y, and we have this tool here, like this we have a tool like this, x and y. So this is called this is the main cutting edge, and this is the auxiliary cutting or the minor cutting edge. ठीक है, minor cutting edge. So the angle between the x axis, this x, and the main cutting edge is called the side cutting edge angle, phi s, or some whatever you denote. I don't know the denotions. Whatever you denote, which is called the side cutting edge angle. Side cutting edge angle, and the angle between this minor cutting edge and sorry, one second, sorry, this is wrong. I'll draw it once again. Wait. I'll draw it once again. See, this is a tool, and this and this. So this is y, and this is x. This is y and this is x. So the angle between the main cutting edge, this is the principal cutting edge, and the y is called the phi s, which is the side cutting edge angle. An angle between the auxiliary cutting edge and x axis is called the phi e, which is the end cutting edge angle. Just you need to understand this one. The rest are same, nothing to take care. So we have learned about 4 angles. Sorry, basically we have learned about 6 angles. One is the side and bake rake angle, then the side and the end relief angle or the clearance angle, the side cutting edge angle, and the end cutting edge angle. So we have seen that. Okay, fine.
Yes.
Okay. So this you need to actually visualize it. I'm showing you with the 3D figure. See, this you can see, this is the reference plane. You can see the down plane. You can see reference plane.
Yes, sir.
This is the reference plane. This is the pi x plane, the plane in the x axis which is perpendicular to the reference plane, and one is the pi y plane, C, which is perpendicular to both. So when you are measuring rake angle, the rake angle is the angle between the reference plane and the rake surface measured along the x plane, the pi x plane, this plane. And when you are measuring the angle between the rake surface and the reference plane along the y plane, this is called the back rake angle. This is the mainly about the rake angle. Now, see, this we have discussed about the AC system, different angle, how to denote it. I'll just move to the ORS system. See, in ORS system, we have 2 other planes. One, this is the reference plane. The blue one is the reference plane. Right? The blue one is the reference plane, which already seen. Now we have two more plane. One is the pi c, which is the cutting plane, and one is the pi naught, which is the orthogonal plane. ठीक है? तो see, pi c I have already told. Pi c is a plane which is perpendicular to pi r, but it will contain the principal cutting edge. So there must be different plane which can be perpendicular to pi r, but there will be only one plane which will contain the principal cutting edge, which is called the pi c. If principal cutting edge is in this direction, then pi c would contain this line. If principal cutting edge is in this direction, then pi c will contain this line. So this is pi c. and one more is the pi o, which is orthogonal plane, which is perpendicular to both. Pi o will be perpendicular to both pi c and pi r. So when the chip flows in the orthogonal plane, this is the orthogonal plane. When the chip flows in this plane, you can see chips flowing here. When the chip flows in this plane, then that is called the orthogonal cutting. The true definition of orthogonal cutting. I have told you that people say when the cutting edge is perpendicular to the cutting velocity, then orthogonal cutting. But however, that is not the true definition. The true definition is such that when chips is coming and it is flowing on the and it is flowing in the orthogonal plane, it is called the orthogonal machining. This is the definition of the orthogonal plane. Similarly, when the chip does not flow or get deviated from the orthogonal plane, it is called the oblique cutting. This is the basic difference between the orthogonal cutting and oblique cutting. So this is the ORS system, and we have different donation. We have discussed this last time, and then we have the NRS system. In NRS system, what happens? This another plane comes into picture, pi n. So this pi n plane is that plane which is perpendicular to the principal cutting edge. See, we have pi c which is containing the principal cutting edge. For example, this is pi c. Then pi n will be perpendicular to this. The pi n is that plane which is perpendicular to the principal cutting edge. So and when the chip flows to orthogonal plane, it deviates by some angle, so that it will not flow in the orthogonal plane, it will flow in the normal plane. So that angle is called lambda. That is called the inclination angle. What is inclination angle? When the chip has to flow, it has to flow in the orthogonal plane, but because of various reasons the chip does not flow in the orthogonal plane, it deviates. There are different reasons about that is a very huge topic to discuss. So you just know that when the chip flow in orthogonal plane, because of various reasons it get deviated from the orthogonal plane and flow in the normal plane. This is a normal, it is flow here, now it start flowing here. So how much angle it get deviated, that angle is called inclination angle, which is very important angle here. So this is about the inclination angle, and tool signature we have already seen. So these are the formulas you should know at least. These are basic formulas you should know. How to convert the orthogonal to ASA to RS. If you want, you can take this screenshot and keep this formula with you. Okay? Can I move forward?
Yes.
Okay. So these are the last topic. Mainly we have discussed everything. The merchant circle diagram and everything we have discussed, right? Hai na? So this assignment practice we have solved. Now we'll come to this week problem, the week 3 contents. So have you solved the assignment 1 and 2? Have you submitted? So have you able to have you solved every questions?
Yes.
Because we have discussed almost every question, right? Like in the practice question.
Yes, sir.
So it would be very easy. Yes.
Sir, in assignment 2, the value of mu coulombs coefficient came around 1.02, more than 1.
Okay. An option was there?
No. It was filling the blanks type question.
Okay. What is in assignment 2? Which question was there? Can you tell me which question?
In an orthogonal cutting,
1 second.
Cutting force is 300 Newton.
Mm-hmm.
And thrust force is 200 Newton.
Okay.
Rack angle is 12 degree.
Mm-hmm.
Effective Coulomb's coefficient is up to. If we put in the formula mu is equal to F by N, and F is Ft sin alpha plus Ft thrust force cos alpha divided by Ft cos alpha minus Ft sin alpha.
Wait, we'll do it. Wait 1 second. We'll do it. Okay. What was the this cutting force?
Cutting force is 300 Newton.
Okay, wait. Cutting force is 300 Newton. Okay. Thrust force?
200 Newton.
thrust force is 200 Newton. 1 second. Thrust force is 200 Newton. Okay. Huh.
And rake angle is 12 degree.
Rake angle alpha is 12 degrees. Okay.
Mm.
Then you need to find the mu.
Yeah.
The mu is what? F by n.
Mm.
F is Fc sin alpha plus Ft cos alpha upon Fc cos alpha minus Ft sin alpha. This formula only you have to put.
Yeah.
So what is the issue in this?
So numerator came around 258.003 and
Okay.
denominator 251.86.
Okay. See,
And the ratio became more than 1.
okay, the ratio become. See, this is not a normal case, but if the value is right, then this same has to be used. Like you have to put the same what is coming. Okay, wait, I'll solve it, huh? I'll check. How much the numerator came?
258.003.
Yeah. Numerator is around 258.003. And numerator how much?
Denominator is 251.86.
Let me check. Cos 12 into 300 minus sin 12 into 200. 251 something, yeah.
Yeah.
Then it can be more than it then it is more than one, no issue. See, it is not a general case, but it can be.
But friction cannot be more than 1.
Yeah, it cannot be more than one, but the thing is ki based on this values, it is like you can't do anything, just you need to answer it,
Okay.
right?
Okay.
So don't worry about that is just a numerical calculations. Okay, any other doubt
Okay. No.
from the assignments? Anyone, any other doubts, previous assignments?
No, sir.
Okay, so it's fine, it was okay na? Okay, chalo. So now we will start our week 3 content, which sir has already taught. Will basically briefly discuss about only the various formulas and small concepts, and then we'll go straight to the practice questions. Today we will solve each and every question. I'll give you time, you solve it, and then we'll see it if you cannot solve, right? Okay. Okay, so please please keep a pen and a paper with you so that you can also solve the numericals. Okay, fine. Can we move forward?
Yes, sir.
Okay.
Yes.
See, so the week 3 contents, which include the strain and stresses in orthogonal cutting, which was taught in lecture 1, the experimental study of the orthogonal cutting and other model, which was taught in lecture 2, and the other analysis of the force, which was taught in lecture 3. So now we'll begin with the strains and stresses in orthogonal cutting. So see, we have already first we will determine the coefficient of friction. We already know, we have discussed just now how to find the coefficient of friction. Before that, I'll just want to light up on certain things. See, when the chip flows, right? This is the tool. This is the tool. This is the workpiece. This is the workpiece. So when tool is cutting, so one part of that, this is the uncut part, right? And this is the chip, which is the cut part. This is all clear. This is the uncut part, and this is the chip, which is the cut part. So first of all, there is two mechanism of chip flow. One is this plane. You can see this plane. This is called the shear plane. This is called the shear plane. Shear plane is that plane, listen very carefully. Shear plane is that plane in which the chip is getting sheared off. It is getting sheared off from the workpiece material. From the uncut part, it is now becoming chip. That plane is called the shearing plane. So number one, we have the shear plane, and number one we have the shear plane, and number two we have the rake surface. So rake surface is that surface. This is the rake surface. See, you can see. So rake surface is that surface at which the chip flows after being sheared. After it is sheared from the workpiece, it flows at that surface. So this second is the rake surface. These are the two more important planes or surfaces in the chip tool mechanism or interface. Right. Now see, we have two surfaces here. One is shear and one is the rake. So when the chip will get shear from a plane, it will develop a force, right? When you when you have a what to say, you know, the wooden box in your houses, when you are using some machine and removing the, you know, the ply, right? Ply, and you are removing the chips using some hacksaw or something, so chips are getting out. So when it is getting sheared on that plane, then forces are developed. So that force have two forces here. One is called Fs, one is called Fn. So if this is a shear plane, so one force is Fs and one perpendicular force is Fn. This is called the shear force because it is developed on the shear plane. And one is the perpendicular to shear force, which is called the normal shear force. So these two forces are developed on the shear plane. Now chip is flowing on the rake surface. So when chip is flowing, when there is a interaction between two surfaces, so some friction will develop. When you will rub your hand, then also friction develops. So here when the chip is flowing along this rough surface, so it is rubbing the rake surface. So some friction will develop. So it will have some friction. For example, this is the rake surface. So it will, if chip is flowing this direction, then friction will develop opposite to that, this direction, right? And because of that, we'll have a normal force also, which is called N. So F is the friction force and N is the normal force. So basically we have four forces. One is Fs, which is a shear force, Fn, which is the normal to shear force, one is F, which is friction force, which is the direction is opposite to the chip flow, and one is N, which is the normal force to the friction force. So this four force we should know what are the different forces, right? This is all about the forces. So this angle we already know. Let me clear this. See here, this angle we have already discussed now. Ki mu is equal to tan lambda. Lambda is your friction angle. Lambda is your frictional angle. In somewhere it is also called beta. So don't get confused. Somewhere it is also called beta. So which is equal to F by N, and you can use the formula and find the mu. Now see, one important concept is there. Please look there. We have already, from here also, from this equation also, mu is equal to F by N, right? Then which means F is equal to mu times of N, okay? And mu is constant. If mu is constant, this means F is directly proportional to N. This means a linear relationship. This you understood? How a linear relationship is developed right now? Okay, but in actual case, this is not the scene. There is no linear relationship between when you see this, because see what happened now. This area is the area which we considered when we considered the friction. which is called the apparent area, which is not the actual area. We considered the only the surface area, which is not have that irregularities. But in actual, there are different irregularities in the surface. See, you can see here. So there comes an area called AR, which is the real area. See, wait, AR is the real area, and this AI is the apparent area. We generally use the apparent area, but in actual, the real area is the AR area. So when we see the graph between the friction force and normal force, so based on this, we always see when AR is equal to A, when AR by A is equal to 1, which means both are 1, we almost get this loop. Almost they are equal. Okay, but when they are not, like when AR is this is when AR is equal to 0, which means there is no real area, then we can find F is equal to mu n, and from here we can draw a straight line. We can draw a straight line showing a linear relationship. But when AR is not equal to 0, it is almost equal to A, the apparent area. So this linear relationship does not follow. It follow a constant path, which is shown in here. This is just for the information कि always this F is not directly proportional to the N. So this is based on the apparent and real area concept. Okay, this is okay?
Yes, sir.
You have any doubt?
No.
Okay. Now friction models. See, now you know there is some term called friction. When friction comes, when two surfaces like slide over each other, then friction come into existence. How to find friction? What is real area of contact? What is apparent area of contact? But to find this value of friction, because in the friction, while determining friction, different stresses are developed in that region. So different models had been stabilized how to find that value of stresses and the friction values. So there are different models. I'll just go through the models and not going deep because this has been already cleared. I'll just discuss the different formulas. One is the Coulomb's law, which states that Ts is equal to sigma equivalent by root 3, where Ts are the tangential component and Tn are the normal component of the stress which is developed in the area, and F is the coefficient of friction. So this, by using this Coulomb's law, we can find this using this formula. One is the Average-Stewart, which use the friction factor to determine the formula. For example, this Ts is equal to m sigma equivalent into root 3. This is the very important formula which is used to find the tangential component of the stress over the friction area, where this m is called the friction factor. And one is Woman and Bay friction model, in which similarly the friction equivalent value of friction is where F equivalent is the coefficient of friction, which is found by using this formula. See, we are finding the same thing only, but different scientists have different approach of solving different condition. So different formulas are coming. So whatever, like, we keep on evolving, different formulas are coming, and like it is making things complex. We are finding the same thing only. So from Woman and Bay friction model found the F equivalent, which is equal to this. So these are the various formula you need to understand, and you need to basically keep in mind. Now, determination of stress, strain and strain rate. See, this is the basic diagram of the tool chip. See, we have a tool here. We have a workpiece, we have a chip, we have a shear plane C, and we have a rake plane. This is the uncut chip thickness, which is not, this is the chip thickness. This is the width of the chip of workpiece, right? Width of the workpiece. Now we have to find different stresses developed here. So we know in the shear plane, see, in the shear plane we have two forces. One is Fs and one is Fn. One is Fs and one is Fn. So based on this Fs, Fn, we will have two stresses. So one would be sigma s and one would be sigma n. Sorry, sigma no, shear stress na. Then tau s and tau n. So what is the value of tau s? the force upon area. The force is what? Fs upon area, and tau n would be force, friction force, normal force upon area. And we know that Fs from the Merchant diagram, we know that it is Fc cos phi minus Ft sin phi, and Fn is Fc sin phi plus Ft cos phi. This we know from the Merchant diagram. So putting that, we can find the value, and the area is also, we know it is Bt by sin phi. This all we have discussed already in the Merchant diagram. So this just, you need to just put the formulas and find this stresses value. So okay, I'll rub it. So similarly, this you have seen the shear stress and the normal stress, how to find, and where B is the width and thickness of the uncut chip thickness. Now we have already seen before how to find the shear strain, which is equal to tan phi minus alpha plus cot phi. This we have already seen before. I'm just writing the formula here. Okay. Also, this shear strain rate can be also written in the terms of zeta. This is called zeta. This is called zeta. One second. This is called zeta. Zeta. So zeta is what? The chip reduction ratio. We have R, the chip ratio, which was what? The uncut chip thickness upon the chip thickness. But this zeta is opposite of it, T psi by T, which is 1 by R, chip reduction ratio. So in terms of chip reduction ratio also, we can derive it. There is a derivation you can see later on. Just you can have this formula. So however, this formula is also not very useful. You need to just know this formula. Shear strain is cot phi plus tan phi minus alpha. So this is about shear and strain. This also we have discussed last class. Now one thing more is there, which is the shear strain rate. See, when in the shear plane, shear stress is generating, shear strain is generating. So there is a rate at which the shear strain grows, or it is getting generated. That rate is called the shear strain rate, which have this formula. This gamma dot is called the shear strain rate, which is equal to Vs upon del V. Del Y is what? Del Y is the distance between two shear planes. And if del Y value is not given, you can directly take it to be 25 into 10 to the power minus 4 mm. So directly you can take the value of del Y to be 25 into 10 to the power minus 4 mm. This is called shear strain rate. Please note these formulas if you haven't. But sir have already taught, so this formula you might have been knowing. So you should have this formula written. What is the value of tau s? What is the value of this normal stress? And then the shear strain in terms of zeta, and the shear strain rate. Okay, can I go forward? Is it okay?
Yes.
Okay. Now we'll see about the velocity triangle. So when we study the merchant circle, so we have a velocity triangle. For example, one is the velocity, cutting velocity. This is called cutting velocity, V. This is the main velocity. This is the main cutting velocity by which the tool cuts the workpiece, right? And this Vs is the shear velocity. This is the velocity at which the chip flows on the shear plane, and this Vc is the chip velocity. Chip velocity. It is that velocity at which the chip flows on the rake surface. On the rake surface. This on the shear plane. So by using the simple mathematics, we can find the we are using here sine law. Sine law what says? You can use the simple mathematics and find the value of this, right? Okay, so from here directly the formula I have written. From here we can find the VC and we can find the VS. VC is V sine phi upon cos phi minus alpha, and VS is V cos alpha upon cos phi minus. This you have to remember. This is very important. This two ratio you need to remember. See, one is VC by V, which is equal to sine phi upon cos phi minus alpha, and one is Vs by V, which is equal to cos alpha upon cos phi minus alpha. This two ratio you have to learn. This is very important. Now, can anyone tell me what this ratio equals to? Sine phi upon cos phi minus alpha. Can anyone tell me? Do you know?
Chip thickness ratio.
Right, very good. This is equal to chip thickness ratio, because R value is equal to sine phi upon V cos phi. So directly we can write VC is equal to R times of V. So this, if you know R, directly you can find the VC if you know the cutting speed. So this is about the ratio you need to know. Now there is one important formula. You know about this formula, tan phi is equal to R cos alpha upon 1 minus R sin alpha. You might have seen this. Okay. Do you know? Hello? Am I audible? Can you hear me?
Yes, sir.
Okay. So there's one very important formula. You can write it, very, very important. To relate the shear angle phi and the chip ratio and the rake angle. This is a very important formula. So if you know this formula, directly you can find different many relationships. So this formula you should know how, like, what is the relation between the shear angle with chip ratio and the rake angle. Okay. Now there is a very important relationship which we will derive now, the minimum power condition. Okay. You know from the Merchant theory what is the relationship between the shear angle, friction angle, and this rake angle. Do anyone know? Do anyone know? Okay, see. We know, right, this strain rate is equal to tan phi minus alpha plus quarter phi. This is okay, right? This we have learned last slide only. Now for the minimum power condition, the strain rate or the shear strain should be minimum. For minimum power, this shear strain developed should be minimum. So when we find the minimum of something, what we do? We differentiate it and put it to 0, right? So what we will do? Del gamma by del phi equal to 0, because rake angle is constant. So when we'll do it, we can see what is 10 of a differentiation of 10, sec square phi minus alpha, and what is the differentiation of cot minus cosec square. So minus cosec square phi equal to 0. So means sec square phi minus alpha equal to cosec square phi. So sec can be written as 1 upon cos. So 1 upon cos square phi minus alpha equal to 1 upon sine square phi. It can be written as sine square phi equal to cos square phi minus alpha. So we can remove the square because both are equal. Then sine phi equal to cos phi minus alpha. See, from there sine phi can be written as cos 90 minus alpha. So cos 90 minus alpha is equal to cos phi minus alpha. So from here cos cancel, so 90 minus phi equal to phi minus alpha. Then we can write 2 phi equal to 90 plus alpha. So phi will be equal to pi by 4, which is 90 by 2 by alpha by 2. So this is a very important relation you get for the minimum power condition. Phi is equal to 45 degrees or pi by 4 plus alpha by 2. This is the equation we get, which I have derived here. Is it okay?
Yes.
So can I go, or you want to write? You might have already written, I guess, before.
Yes, sir.
Okay, so I'll move forward then. Now, when you use this, then you got the formula phi is equal to pi by 4 plus alpha by 2. So using this formula here, in 2 phi plus alpha, this is the merchant formula. This is the merchant formula. Using that formula, phi is equal to pi by 4 alpha by 2. You put here, then you get this relation. Right? This is a very important relation you get. So based on this, you have one theory called the Lee-Shapler strip line field theory, in which you find the cutting force. So the value of cutting force comes to be, see, don't go for a derivation of this, just remember the thing, because this is not very important. Just you need to know because of the minimum power theory, you get the Lee-Shapler slip line theory, which have the cutting force, which have the value of kbh 1 plus cot phi, where f is the cutting force, h is the uncut chip thickness, b is the width of the chip, shear stress k, and phi is the shear angle. So this formula you need to know for determining the cutting force using the Lee-Shapler strip line theory. This is just formula you need to know. Now see, we have seen cutting is there, then chip will flow, right? Then if chip is flowing, so chip is very small, small entity. If you want to study the chip, you need to know the various method how you can study the chip morphology, or various factors which is happening on the chip, because studying the chip alone you can know what are the various parameters which are used in the, because chip is a very critical parameter used in the machining. Because if you can see if your chip is getting thinner or chip is getting hot, then what is the based on that you can do the force analysis, you can do the temperature analysis. So chip is a very critical factor of the machining, so you should know how to evaluate the chip formation. Okay, so there are 3 different experimental study of chip formation. One is this, the study of deformation of rectangular or circular grid mark on the side surface. One is the microscopic study of the chip frozen by drop tool and quick soap apparatus. One is study of the running chips. So basically, see, the morphology of chip is study using the various high speed cameras. So by using the optical cameras, or there is a machine called SEM, scanning electron microscopy, so which have very high resolution and very high magnification, so that you can determine the chip, what is happening on the structure of the chips. So that is different thing, you don't need to know much about that. So this is one of the method called is rectangular circular grid. See in this particular thing, in the chip you have the rectangular grids, you can see, right? Rectangular grids, but here you have the circular grid. So you can see difference in the grid. So this difference in the grid is suggests you the strains which are developed in the chip. So by studying this deformation in the grid, we can study the strain which is developed in the chip. So if we'll see the estimation of the strain by the study of circular grid deformation, you can see first the deformation was round, which are having a radius r. See here, the deformation was round, this deformation was round. If I'll see, deformation was round, Then slowly it got distorted and it started becoming ellipse. So that is what I'm trying to say. First deformation was round. It was a circle. And then when the chips got like forced and posed and deformation started continuing, it became a ellipse. It became a ellipse. This is a deformation. This means strain has been developed here. What does strain do? It either elongate or compresses the material, right? So now it has compressed the circle from both the side, from the minor edge side and the major edge side. This R1 is called the major radius and R2 is called the minor radius. So to find the strain developed, we can use these formulas. If strain developed in the major edge is ln R1 by R is the this radius, R1 is the major cutting radius, major radius, or E2. This is called E2. Sorry, E2 for the minor one. This is for the major one, major strain one. This is for the minor strain one. This is called ln R2 by R. R2 means this is this direction. And if this is the 2D object, when we'll have a 3D object, then we will have some E3 also. Then the sum of all strain is 0 because the volume remains unstrained. Because of that, the sum of all strain will be 0. So this you need to understand how we to find while the chip formation, while the chip deformation, the grids will change. Because of the change in the grids, the strains will be developed and the circular grid will change into the elliptical grid, and then the changes in the dimension in the both major axis and the minor axis, and how to find that strain value E1 and E2. This is okay? Okay, then we'll move to the next slide.
So how E3 is determined?
Yeah, see, E3, there is, for example, see, I have considered it as a 2D object, right? Because some circle is there, na? Circle is a 2D object. But if, for example, some disk is there, circular disk, for example, this is there, and it has some thickness, right? This is some disk. So it is the circular plate with some thickness, for example T. Okay, then if I'll change it and it will become an ellipse, then there will be some change in the thickness value also. If it is T1,
Yeah.
it will become here T2. Then we'll find E3 how? ln T2 by T1, right?
Yes.
This is where you determine E3. Fine, na?
Yeah.
Okay. Okay, we'll move to the next slide. Now, see, we have two parts in the chip. One is the chip thickness, which is getting removed, and one is the uncut chip thickness, which is getting removed. Right? So there is a method. There is a method to determine the uncut chip thickness, which is using the weight measurement. So in this, the weight is remaining same. If we consider the condition 1 and 2 and weight remaining same, so weight is what? Rho into volume, density into volume. So density is density, and for volume what is there? Length, thickness and width. So weight is equal to rho L T and width, where rho is the density of the material, L which is what we need to find the length, T is the uncut chip thickness, and small w is the width of chip. So from here you can find the length of the chip, uncut chip thickness, length. How to find the length? If we know the weight of the chip and density of the material, we can find the length of the chip, uncut chip material. And this T1 and T2 can be found through this formula. T1 is the uncut chip thickness, which is a very famous formula of turning. F cos phi. Of psi is the side cutting edge angle, and W is the D by cos psi. This is a various famous formula in turning. So using this formula you can find the. This is very simple. This is not must to be taken care. Just you need to remember this formula. Okay, how to find the length of the uncut chip thickness. Okay. Now there are different modeling to study the orthogonal machining process. However, like final element, the different simulation modeling has been done, different analytical modeling, the different experimental modeling has been performed to study the orthogonal machining process. So there is also called, one is the final element modeling. In final element, by you do the simulation. See, because studying the chip experimentally is very difficult. Therefore, we used a, you might have heard about the ANSYS and Abacus. These are the software which are used to simulation, because you can't perform everything experimentally, so you simulate it using the softwares, so that you can study the variation of forces, study of variation of temperature, so that you can experiment, so that you can study it and find the various variations of chip. So one of the this is the final element modeling, in which we have different relations. So one of the relations is the strain rate and velocity relations. So this is the strain rate and this is the velocity. So if you want to find the strain rate in x, this is for the 2D 2D object, 2D flow. Then strain rate in x is given by del Vx by del x, and strain rate in y is given by del Vy by del V. And strain rate in xy direction, it is given by half into del Vx by del x plus half plus del Vy by del y. So this formula you need to know. This comes from the, this can be derived using the fluid dynamics and other stuffs. So I don't want to go there. Just you need to know this is the relation between the strain rate and the velocity vector. Is it okay? Okay, so now the theory part is over. Now we'll go to the practice part, the question part. We have 10 questions which are related to the assignment question only. So we'll solve it and have a practice. So all of you please bring the one copy and one pen. Do you have a copy and a pen?
Yes, sir.
So can we start it?
Yes,
Hello?
sir.
Yes, sir.
Okay. So see, the first question is, in an orthogonal machining, the thrust force is 9 Newton. Means whenever you see the question, just write what is given. Thrust force mean Ft is 400 Newton, and the cutting force, which is Fc, is 550 Newton. The rake angle alpha is 10 degrees. Then what is the friction angle? Friction angle is what? Beta or phi, whatever you say. Beta, for example. Can you do this? Hello?
Yes, sir.
Please do it. I am giving you 2 minutes. Please do it. Then we'll discuss. Let me know the answer. Have anyone got any answer? Please keep
46.02 degree.
How much?
46.02 degree.
46. Okay. Anyone got any other answer? This is very simple. You can do it instantly. It's very simple. Just you need to put in the formulas. Okay. See, I'll solve it. You have FCFT, na? So what you know the friction angle. So you know mu is equal to 10 beta, which is a friction angle, which is upon F upon N. तो F is FC cos alpha plus FT sin alpha, and N is FC sin alpha minus FT cos alpha. Just put the value of FC, FT and alpha, then you'll get the value of tan beta. How much tan beta you got? Hello? Nikhil, right? You got the answer? Can you hear me? Hello? Hello?
Yes, sir.
What is the value of 10 beta you got?
45. 10 beta 1.03.
Yeah. See, here also value of mu is greater than 1, right? So it can be greater than 1, there is no issue. This 10 beta is mu only, na?
Yes.
You got 1.04 something, 03.
3.
And from here beta you can get 46 degrees something, na? 46.0203 degrees.
45.84.
Something similar only, 45, 46 degrees. So like this you can get, right? Everyone got this? Is it okay?
Yes, sir.
Is it fine, na? No, anyone having any doubt?
No.
Can we go next question?
Yes, sir.
Okay. The next question is, the yield stress of a material without strain hardening is 300. The friction factor is 0.3. What is the frictional shear stress? It is very simple question. Can you do it, please? The yield stress means the sigma value is given 300. The friction factor is given 0.3. You need to find the frictional shear stress TS. Please find it. Please use the formula and find it. I'll giving you 3 minutes. Please do it, because when you do it now and you write the formula on the paper, then only you'll remember the formula. Have anyone got?
27.71.
What is the formula you have used?
सिग्मा y अपॉन रूट 3 ब्रैकेट में 1 माइनस अंडर रूट 1 माइनस m.
No, why you are using this formula?
51.96.
Yeah, because TS is equal to what? M sigma y, the sigma y upon root 3, simple na?
Okay.
Then M you know, 0.3, sigma y is 300 and upon root 3, the answer will be 51.96 something, right? Is it okay?
Okay, sir.
You have done, or can I move forward? Can I move to next question?
Yes, sir. Yes, sir.
Okay, fine. Now the third question. See, the friction factor is 0.4. Now M is given 0.4. Now the equivalent Coulomb coefficient of friction in the using the WAM and Bay model. So you have a formula for the WAM and Bay model. Just use that formula and find the value of the friction factor F. F equivalent. Please see the formula and find the answer. Please do it. You just need to put value in the formula, nothing else. It is very easy question. It can only have a calculation mistakes. Other than that, it is very easy. Please do it. My screen is visible, na?
Yes, sir.
Okay, fine. Have anyone got any answer? Have anyone got any answer?
Formula not remember.
You don't know the formula?
No, sir.
See, I have shown you now only. M upon 1 plus pi by 2 plus cos inverse m plus 1 minus m under root. Just do it.
Oh,
You can do now, right?
yes, sir.
Just keep in mind when you are putting cos inverse m should be in, you should put in radian, na, because m is not a degree.
So this m is in degree or radian?
M is 0.4, na, it is radian. You need to use cos inverse m and should be in 0.4 like radian, because pi by 2 is also radian, na, it's not 45 degrees. Have you got? Just you need to put the values, right?
5.73 into 10 to the power minus 3.
No. 0.4 upon 1 plus pi by 2 plus cos inverse 0.4 upon plus 1 minus 0.4. So you will get around 0.089 something. Please check once. Use cos inverse, na?
We will take pi 3.14.
You can take.
Zero point zero nine zero two eight.
Right. Almost like that. Okay, fine. 0.09 something, right? So that is
Sir.
near to this value you'll get 0.09 something, 0.09. It is same only. So just you need to put the formulas and remember this is in radian. Don't put it in degree. That is a major mistake you can do. So can I go to next question now?
Sir, how to identify whether it is given in degree or radian?
Because see, first of all, it is just mentioned a number, right? It is nothing given. If it is degree, then it might have given 0.4 degrees for first thing. Okay, first thing. Second, also see this term pi by 2 you can see.
Yes,
So
sir.
pi by 2, pi by 2 is how much? 45 degrees, na? Pi by 2 is 90 degrees, na? You know pi is 180 degrees.
Yes, sir.
Then pi by 2 is how much? 90 degrees. So this is the degree, this is the radian. It is given in radian form, right?
Yes, sir.
Therefore, entire you should use in a radian form. Okay?
Okay, sir.
Understood, na?
Yes, sir.
Okay. So I'm moving to next question. See, what is given? The thrust force and cutting force. Just write. Keep a habit. Just see and write. Ft is how much? 400 Newton. Fc is how much? 600 Newton. If the shear angle phi is how much? 30 degree. Uncut tip thickness means T is how much? 1 mm. And width B is how much? 4 mm. The shear stress tau s is how much? It is very easy question. Just use the formula of shear stress. Can you solve it?
Yes, sir.
Please solve it. Just use the formula. Shear stress is equal to shear force upon area. So what is the formula of shear force and what is the formula of area? Use both formula and find the solution. Have anyone got?
39.95.
39.95. Okay. So let's see. So you have the shear stress tau s, which is equal to Fs
Sir,
upon area, right?
39.94.
Fs is how much? Fc cos phi minus Ft sin phi upon area is how much? Bt by sin phi, right? Just put the values.
Yes.
So how much you got the answer?
39.94.
Something 9594. Okay. This is will be the megapascal. This is the value. Please everyone check from this. Okay, so can I move to next question? Is it okay
Yes,
now?
sir. Yes, sir.
Okay. Now next question. Now it is given the cutting force and thrust force. So Fc is 650 Newton and Ft is 380 Newton. The normal force on the shear plane means the Fn is given 700 Newton. Normal force on the shear plane. The shear force on shear plane is Fs and the normal force is Fn. Find the shear force Fs. Can you do this? Huh?
Yes,
Yes,
sir.
sir.
Please do this. Just think how you can play with the formulas and find this. Just you need to play with the formula so that you can develop a relation between this four. Three is there, one this four, and find the relation.
Two 77.31.
How much?
277.31.
Okay. How you got this?
Sir, by the relation of resultant. Resultant is equal to under root of fc square plus ft square and under root of equal to r equal to under root of fn square plus fs square.
Okay.
So this relation equate.
Very good, very good. This is absolutely right. This is equal to fc square plus ft square, which is also equal to fs square plus fn square.
Yes,
So
sir.
fc square plus ft square is equal to fs square plus fn square. So all you just need to find the fs. How much you got?
277.31.
This is the answer. Please everyone check. This is okay with everyone?
Yes, sir.
Okay, then I'm moving to the next question. The rake angle of the tool alpha is 5 degree. The shear angle is 30 degree. Phi. Cutting speed V is 50 meter per minute. What is the chip velocity VC? Can you find this? We have a relation between VC and V. I told these are the very two important ratios. Use that ratio to find the VC. It is very easy.
0.459 meter per second.
0.454.
9
Okay, fine. One answer we
means
have
equivalent to 0.46
0.46
meter
around,
per
na?
second. Yes, sir. 0.46 meter per second.
Okay, rest. Can you do it? So it is very simple. We know that Vc by V is equal to
Yes, sir.
sine phi upon cos phi minus alpha. So Vc by V is how much? 50 is equal to sine phi is 30 degree upon cos 30 minus 5. Just solve it and find the value of Vc, but it will come in meter per minute. Then divide Vc by 60. You will get in meter per second. Right? This is right, na? Have you done this? Have you done like this? Hello? Is it okay for
Yes.
everyone?
Yes, sir.
Just you have this formula, na? Vc by V is equal to sine phi upon cos phi minus alpha. You have every value, you put and find Vc, but that Vc is in meter per minute. Then you will get answer in meter per minute, but you want answer in meter per second. And what you will do? 1 minute is equal to 60 seconds. Divide by 60, you will get meter per second. So 0.46 meter per second. Right? Can I go to next question?
Yes, sir.
Okay. Now,
Yes, sir.
the next question is, during a plane strain deformation circle, a circle is there which is having a diameter of 5 mm. It is changes to a ellipse. We have seen this, which is having a major diameter with this value. The value is 7 mm, and a smaller minor diameter which is having 2 mm. The major strain. The major strain means E1. Can you find this? Just put the formula. Just put the formula, nothing else.
Point 34.
0.34. Everyone is getting same thing. What we do? ln R1 by R we use, na?
Yes, sir.
So R1 is here what? 7 by 2.
7. 7.
And R is 5 by 2.
Yes, sir.
So ultimately 7 by 5 only. So answer is 0.33 something, na? Right?
Yes, sir.
Everyone got this, na?
Yes, sir.
Yes, sir.
0.336.
Okay. Then we will go to next question. 8. Now, you have to find the length of the uncut chips. So what is the formula of length? L is weight upon rho W1 into T1. This is the formula. Directly I am writing the formula. What you have given? Weight, you know, weight you have given 50 milligram, and density is given 7000 kg per meter cube. Chip was produced in the lathe with this feed is given 0.2 mm per revolution, and depth of cut D is given 1 mm, and side cutting size is given 22 degree. You need to find L. Can you find it? Just use the formulas. But keep everything in one unit. See, it is in milligram, it is in kg. Rest are in mm, this is in meter cube. So keep everything in single unit. Just you need to first find small w1 and small t1. I have already told you the formula for small w1 and small t1. You have t1 is equal to f cos psi and w1 is equal to d by cos phi. Just use it and find the. Can anyone tell me the value of t1 and w1 first?
0.2157 T1.
0. No, please check it. Check it. F is what? F is 0.2 into cos 22 degrees. This will come in mm. Please convert it into meter then. Do 0.2 into cos 22 do. And wait 1 second. It is in mm, right? So please do 0.2 into 10 to the power minus 3 into cos 22. Because this is in mm, I am converting it to meter. And this is d is also, so I'll do 1 into 10 to the power minus 3 upon cos 22. So this then T1 will come around 0.185 in 10 to the power minus 3 and W1 will come around 1.079 10 to the power minus 3. Have you got this answer?
Yes, sir.
Right now? Then just put in this then L you will get around how much? 35.78 into 10 to the power minus 3 meter. This weight will be 50 into 10 to the power minus 3. Sorry, 6.
T1 is coming 0.203 into 10 to the power minus 3 meter.
0.185 it is coming. Please check. Point 185 10 to the power minus 3 it is coming.
Yes.
And then
Yes, sir.
W1 and C. You need to convert this. This is 50 grams, 50 milligrams. Then 1 milligram is equal to 10 to the power minus 3 gram, and 1 gram is 10 to the power minus 3 kilogram. Then this will be 50 into 10 to the power minus 6 kg, right? Just use this. This you understood, na? 50 milligram should be equal to 50 into 10 to the power minus 6 kilogram. The final answer will be this 35.78 10 to the power minus 3 meter. Please do it.
Yes, sir.
Done? Everyone done?
35.71.
Okay. Can I move to next question?
Yes, sir.
Okay. See. The uncut tip thickness. See here, using the Lay-Schaeffler's lifeline theory, you need to find the cutting force. You remember the formula of cutting force? It is KBH 1 plus cot phi. I taught just few minutes back. So what is K? K is the shear stress which is given 450. B is the width of chip, which is given 1 mm. Oh, sorry. Which is given 1 mm. H is the uncut chip thickness, which is given 0.6 mm. And phi is the angle, which is given how much? 30 degrees. So just put it here and find the solution. Please find it. Please do this. You just need to know this formula, nothing else. Have anyone got any answer?
Seven 37.65.
Yes, sir. 737.667.
Okay, fine. So the answer is FC is equal to 737.65 Newton. Right? Okay. Can I move to next slide?
Yes, sir.
Okay. So now the final question. You have Vx and Vy. Can you find the value of 600 times of strain rate of y? Please do it. Use the relation between the strain rate and the velocity and find the value. Acha, this is one. I am adding one more question. Also find 500 times of epsilon xx. Please do both the questions. 600 times of epsilon yy and 500 times of epsilon xx. First, you need to find the relation between this and how it is done. How the epsilon xx is found, how epsilon yy is found.
Four point two and 2.
4.2.
2.
Okay. So how to find epsilon yy? It is del v y
Del V
upon del
upon-
y, right?
Yes, sir.
So it is how much you will differentiate it. How much it will come? 7 to the power minus 3.
Yes, sir.
Similarly, epsilon xx is how much? Del vx upon del x, which will equal
Yes,
to
sir.
differentiate this vx with respect to x. You will get 4 into the power minus 3. Then then multiply this with 600 and this with 500. Your answer will come. Right? Right now?
Yes, sir.
Yes, sir.
So, okay, our set of question for today is complete. So if anyone having, we have 10 minutes. If anyone having any doubt, we can clear it. Similar set of question you will find in the assignment, and your due date for assignment is 15, right?
Yes, sir.
So please do it before 15, and I think after solving this, practicing this, you will be able to answer each and every question very easily.
Sir,
Yes.
sir, in assignment first, question
Uh-huh.
number 11,
Okay. Wait 1 second. I'll go there. I'll just discard.
not practice assignment, given assignment.
Yeah. I'm given assignment. Okay. 1 second.
Magnitude of true strain is always less than the engineering strain.
Okay. Hmm.
So this is true.
What you are saying?
Sir, true strain is always less than engineering strain. So this statement is true.
1 second. Magnitude of true strain is always less than
Always less than
the
engineering strain.
this is
Engineering
true.
strain. Yes, sir.
You are saying this is true.
Yes, sir.
How you can prove that it is always true?
Uh, Putting any numerical value, if engineering strain 0.5, then longitude, then true strain is 0.405.
Okay.
So this is less than the 0.5.
Okay. Let's try once, है ना? If
Yes, sir.
a length is, for example, 1, now I have increased it to 2,
2.
right? So
Yes, sir.
so the engineering strain would be 2 minus 1 upon 1, right?
Yes, sir.
Which will be
Yes, sir.
1, right? Na?
Yes, sir. Yes, sir.
ठीक. Now finding that true stress, true strain. It is
True
what is
strain.
ln 1 plus engineering strain.
Yes, sir. By 0.693.
So ln 1 plus 1, which is 0.693.
Yes, sir.
This is
Which
right.
is less than.
In this case it is right.
Yeah.
But if you do the strain
Yes, sir. Compression.
compression, I'll rub it.
2 to 1.
2 to 1.
Yes, sir.
Then your engineering strain value is
Minus 0.5.
minus magnitude is 0.5 only.
Yes, sir.
So same way, then it is true then. It is true then. What is the issue?
But my answer is wrong. I answered true,
Okay.
but after checking, wrong with me.
Okay. Wait, let us check 1 second. Na? You get wrong. Let us check once.
Yes, sir.
For example, your engineering stress value is minus. No. Yeah. Now I'll tell you. Wait. Your minus 0.5, right?
Yes.
Then the magnitude of engineering stress is 0.5. But when you'll find the true stress, it is what? ln 1 plus engineering. So 1 minus 0.5. So
Yes, sir.
ln 0.5. What is the value of ln 0.5?
Minus 0.69.
Minus 0.69. And what is the magnitude of this value is 0.69? Then 0.693
Okay.
is greater than 0.5, na?
Yes, sir.
Then the true will be greater here in this case.
Magnitude in the mode option.
Yeah, magnitude means you are not taking sign, only the value.
Okay, sir.
So in tension this is right, but in compression it is wrong.
I taking the with sign, so minus 5 is more than the minus
No.
0.69.
Magnitude. You have to check magnitude. Magnitude is only the value without taking the sign.
Okay. Okay.
Understood?
Yes, sir.
Okay. In case of tension, it is true. True is always less than the engineering. But in case
Yes.
of comparison, it is false.
Sir,
True is
sir,
more
sir,
than.
sir.
Yes,
Sir,
yes.
if magnitude word erase, the
Huh.
only statement true strain is always less than the engineering strain, then it is true.
Huh. It is true then. It is true then. If magnitude word is not there.
Yes, sir. Yes, sir.
Huh.
Okay, sir.
Anyone having any other doubt?
No, sir.
So we can wrap up. Hmm?
Okay, sir. Thank
Okay,
you, sir.
sir. Okay, then we'll meet on next week. And like those who want to see this today recording, you can see in YouTube, which is my YouTube. I'll upload this. Wait, 1 second. I'll upload this video on Abhishek's NPTEL tutorial. NPTEL tutorial. Right? You can watch this video which we have discussed today. If you want any doubt and you want to re-watch it, you can watch in Abhishek's NPTEL tutorial and like clear your doubts. And furthermore, if you have any doubt, we will discuss on next week. Fine?
Okay.
Sir, can
Yes.
you please tell the answer of 600 epsilon yy? I got 4.2
Answer of
epsilon yy. 600
1.2.
epsilon.
Just you need to multiply. Its answer is 4.2. Yeah, right.
Okay.
Yeah. Okay then. Okay, we'll meet on next week. Next week. All the best for your assignment. Thank you.
Thank you.
Thank you, sir.
Okay.